Today, we're extremely happy to welcome David Flynn on the show. David is the CEO and founder of Hammerspace, a data orchestration company that's doing some really interesting things. David, thanks for joining us today.
Frank, really glad to be here. Thanks for having me on.
To start us off and kind of set the stage, could you give us a bit about your background and your relationship with data over your career?
Oh, gee. Well, I'll be dating myself, but I taught myself programming when I was in high school on the Commodore 64. I had to confess that to Steve Wozniak when he was working with me at Fusion IO, that I grew up on the poor side of town and couldn't afford an Apple computer. My father was in the Strategic Defense Initiative, the Star Wars program. So it gave me some exposure to that sort of thing. And in high school, I ended up with a job working at Computer Science Corporation and built a flight simulator for an Army missile system. So my first start was building three-dimensional graphics stuff while in high school. But the largest claim to fame to date, because Hammerspace is definitely going to be a much bigger deal, was the company Fusion IO, where we introduced high-performance solid state for enterprise in mass. That was what ultimately became NVMe, form factor flash, but in reality, it was the first high-performance SSDs, period.
So this is a really interesting disruption story, I would say, just solid state drives and flash storage overtaking hard spinning disk drives. How did you end up being early into that disruption?
It was purely luck for where I had been in my career. I had gone from doing embedded systems, Larry Ellison's Network Computer Inc., to building very high-end supercomputers. And this had given me exposure to NAND flash technology, as you might embed in consumer electronic devices, and then the architectures and design for massive parallelism. And see, these tiny embedded systems and very large supercomputers actually are more similar than you would think, because on both ends of that spectrum, you have to eke out every last ounce of horsepower of the hardware. It's in the middle that you get fat and lazy. It's in traditional corporate IT that you're kind of sloppy with all of that. But if you're building a mobile devices or a cell phone or something, especially back in that era, you didn't have any kind of leeway to give, and the supercomputing as well. The interesting part here, Frank, is that consumer electronics and very high volume is ultimately what drove the demand and volume for NAND flash.
It's a common thing we see. You could look at battery adoption in electric vehicles similarly, where a technology comes out that's better on some metrics, but maybe more expensive when it first comes out. And you need something to drive demand to increase unit production, to bring costs down over time, that actually expands the market opportunities where, the first Teslas were very expensive, but over time costs have come down to the point where now the total cost of ownership of a Tesla Model 3 is lower than a Toyota Camry. How has kind of the evolution of data centers changed an organization's relationship with data? And how does that really tie into your move from the hardware space to the software space with Hammerspace?
Well, Hammerspace is really an outgrowth of the experience with Fusion IO and the realization that managing decentralized data, having data be physically distributed across flash inside of servers, in the case of Fusion IO and solid state, or across separate third-party storage systems and cloud services, or across whole data centers. These are three different scalings of the same localization problem. And data today is a highly localized asset. The computing has to happen in close proximity to the data, and the data is very immobile. We still live in a world where data, the main mode of using data is store and copy. Storage is the entire multi-billion-dollar data storage industry, and copy is in one form or another the foundation of all data management and the entire multi-billion-dollar data management industry. And it is our contention that that entire methodology is broken, and that we ultimately have to move to where data is presumed to always be in motion and simply accessible from anywhere, while the data is moved from behind the data presentation layer, behind the file system, and having it so that data is continuously accessible from a file system capable of spanning all of this infrastructure, and putting the data movement function behind this global parallel file system. That's what is data orchestration. It's not just data management by another fancy name, because data management presumes that you're copying stuff from without. This is where the movement is happening from the inside, and that means you're actually solving the seeming paradox of how do you have data local to all of the places where you might need it, local to different data centers, local on different storage systems, even local on the different servers with their embedded flash. How do you have data local in all of those places without ever having copied it? It seems paradoxical to say you've never copied it. Well, how can it be local there? Well, in our world, those aren't copies. The file system, the global file system, has simply moved the data to be on the right system where you're going to need it. That's data orchestration, where the movement happens transparently from within, not as a copy from without. And what we're seeing that is so amazing here is that AI workloads need real file systems and need to be able to move quickly, because researchers don't have time to go and recode everything to use object gets and puts. So even very, very large scale, these hyperscale companies that are at the forefront of the competition with AI, they suddenly have found religion and need real file systems, shared file systems, not local file systems, but a global file system. So it has really been, you could say, a perfect storm for the need for Hammerspace, because now you need to collect data from many different sources and feed it not just to one, because it's not just one AI, it's many different models. And you need to feed it into each of those. And these are overlays. This is separate from the application that was using that data in the first place. So while we used to have a one-to-one relationship, this application put its data on this storage, this application put its data on this storage, maybe they shared the same storage system, maybe a different bucket or something, or maybe they weren't, but you really had, a one-to-one. Now you have a many-to-many. We have to collect up data from many different data sets and feed it into many different models. Oh, and there's a third many, because these are all cross products, and it's a three-dimensional cross products. Many applications, many different models that they need to be fed to, and that you need to run it and in different distinct data centers where you have different hardware. So Hammerspace is solving the issue of decentralizing data so that you can solve this many to many to many problems in the AI world. And it's solving how to feed data at super high performance for read workloads, for the ingest of data, for write workloads, for the checkpointing to capture a snapshot of the state of things so that you can restart when something fails. Because when you're doing, thousands of GPUs, something's going to fail and you don't want to throw away the entire job. File system also means that the operating system knows how to attach to it natively and consume data from it through traditional read and write interfaces, so that applications don't have to be rewritten. And that's because many of these AI applications, most if not all of these AI applications, speak, POSIX file IO, depend upon the OS to do that thing.
That last part's the difference in read this file from the file system, which is a very straightforward thing you learn in Python 101, and get this file from an Amazon S3 bucket, which is a different set of code you need to write versus if you're getting it from Azure Blob Storage versus any other type of kind of what looks like external storage.
Another way to say it is we've implemented the most universal interface to data. one of the companies that I have history with, I can't state names, sold product to them in the past at other companies, is at the forefront of the AI arms race because they have a platform where they can directly monetize this with their very large user base. And they have now adopted Hammerspace as the data platform for that AI work. And so some of the language models that are out there now are being trained using Hammerspace as the data ingest, as checkpoint, as the AI researchers scratchpad. I'm super stoked about that because I had been, tracking what was going on with language models and so forth, and just it's jaw-droppingly impressive to see what's going on there. And now to be able to have a part in that is very rewarding. And the interesting part about this, Frank, is that it's recursive. Hammerspace abstracts data from the infrastructure so that we can allow the movement of data to happen transparently, not disrupt how you're accessing it. Well, that allows us for the first time to truly automate data movement. And what we have done as a company is we've used a machine learning technique to decide where to place data and when to move it using a financial arbitrage simulation. It is more of a machine learning technique. It's the wisdom of the markets. It's using a resource auction model to determine what data down to the individual files should live on which storage systems across a global environment. And it's interesting that if you think about it, what we're talking about here is enabling AI to be used to accelerate the rate at which we can do the AI research and AI innovation. I am a software engineer by trade, and doing Fusion IO and NVMe Flash was really a means to an end. This is the logical conclusion of that is then how do you put a file system across that flash that's scattered throughout servers? How do you put a file system across the different storage systems and services on-prem and in the cloud? And then how do you put that file system in a way where you can have the same file system be serving data from within multiple data centers, active, read and write, and it's the same data set. If you think about that, this is really what's kind of missing from internet. Internet had a model of being stateless, right? It's completely stateless. Well, how do you have now durable state, and especially valuable and data that needs to be secured? How can you have that spread at a global scale? And data orchestration sort of provides that notion of durable persistence of data that can even go across organizations. And the beauty is it's always in the same file system, secured by the same access controls, the same audit trail. By eliminating data copy as your principal mechanism for moving data, now you can keep Pandora's box closed. Because as soon as you copy something, you've scattered it to the wind. There's no way you can collect it back. You don't know where all it goes. But within Hammerspace, if I change the permissions on this file, it's changed globally. If I set up audit trail, I've got an audit trail globally. And I can tell whoever accesses it, wherever they access it. I would argue that compliance and security have largely been theater until you can move away from copying data as your main tool of data management, because copying violates any of that.
So I think that's a good place to end it. Thanks so much for coming on the show, David.
My pleasure. Thanks, Frank.